This is the RabbitMQ team with guests from AWS this time. I'm Michał. I'm on the RabbitMQ team at VMware. Carl?
I'm Carl. I'm on the RabbitMQ team as well. I've been heavily involved in the development of Quorum queues, which is today's topic. Michael.
Yeah, my name is Michael. I'm also with VMware, and I'm a RabbitMQ contributor of 13 years or so. Alex?
Hello, name's Alex. I'm a developer for RabbitMQ for Amazon MQ at AWS. Simon?
Hello, my name is Simon, and just like Alex, I'm working for Amazon MQ and specifically the RabbitMQ part of that team under the AWS.
Awesome.
Thank you.
Yeah, so today's topics will be basically around quorum queues. Quorum queues are super important for us. They basically replace classic mirrored queues. In version 4.0 of RabbitMQ, which we expect next year, there will be no classic queue mirroring. It will be completely removed. So whoever is still using classic mirrored queues should definitely start thinking about moving to quorum queues. They offer much better data safety. They offer higher throughput, lower latency. Basically, they're better in basically every dimension. But they're also a bit different in terms of features they support. It's basically the same, but they behave differently in certain scenarios. Yeah, Michael, if you could just say a few words about like where did quorum queues come from? What were the problems with classic mirrored queues that we wanted to replace them, and why we are getting rid of them?
Oh man, where do I start? So originally, RabbitMQ was an implementation of an immersion messaging protocol, and there wasn't a lot of focus. A lot of focus on replication. So in other words, for classic queues, mirroring was a bolt-on, and as we know, well, at least in this community, bolting on a distribution layer on top of a feature set that was not designed for it usually doesn't go very well. That is exactly what's happened to classic mirrored queues. In my opinion, they have three primary issues. If you're interested in a talk about this, Carl and I did a talk in 2017, I think, at Spring One. So Google something like Spring One RabbitMQ quorum queues, and you will find that talk. But I think some of the key issues are, first, classic mirrored queues use a ring topology, which basically means the more nodes you have, the slower things replicate, which is not exactly what a lot of people expect. Next thing is it uses a homegrown, I don't even know if you can call it a consensus protocol, but something that sort of kind of tries to reach consensus. Sometimes it even works. And yeah, so there were basically distributed system design decisions. And those things are very, very expensive to fix, to eradicate. I would say in this case, is just not possible at all. And finally, to add insult to injury, classic mirrored queues, when a replica fails and then comes back, or a new replica is added, it has to sync. Well, when a new replica is added, surely it has to synchronize every single thing, right? But when a replica fails, then quickly comes back, which is a fairly frequent operational scenario. In the specific case of classic mirrored queues, it also has to sync everything. That means that, you know, thundering hertz, other kinds of scenarios where your network is overloaded by the system itself, they're fairly common. So around maybe 2016, our team, which back then was, I think, 3 or 4 people or something like that, so really, really small, we decided that the only ways to fix this is to build an alternative, put it out there, and then eventually deprecate classic mirrored queues. Around that time, our team had a chance to hire 3 or 4 more people. This is how we got Carl, Arnaud, Diana, and I think one other person who is no longer on the team. So in the specific case of Carl, he had prior experience with a Raft implementation. So during our interviews, we don't do whiteboard, please balance red like tree, that kind of thing, because I find that just insulting. So what we discussed was a number of actual problems in RabbitMQ and how Carl would approach them. And we ended up discussing quorum queues and what a queue implementation on top of Raft would look like. Well, long story short, and maybe this is a good segue to Carl, we ended up hiring Carl and giving him the freedom to implement Raft and design a queue type that would not have all the aforementioned limitations. So Carl, anything that you would like to add about the early days?
Yeah, no, I mean, that's pretty much it. I mean, we didn't really feel that we could fix classic mirrored queues and be sure that we had fixed it. Right? We could probably spend effort and make it better, but could we be sure? And so the idea of using Raft means that we sort of basically outsourced the part of the problem solving to, what was already there, and we could sort of sweep up a whole bunch of features like replication, data safety, leader election. Not easy, and that's part of the reason why classic mirrored queues struggled, is that they didn't have a reliable means of electing a leader. And I think many other systems have quite ad hoc approaches to leader election, which, if you look at them, they look great, prone to race conditions and so forth. But I did a because we just push our talks here. I did a talk last year about quorum queues, as a quorum queues retrospective, which sort of I think covers a lot of sort of design benefits that we got from using Raft and some of the problems that we had. But it was funny, Michael talking about the interview I had with Michael, and that's 8 years ago or something like that, right? It took an ages to actually come on board. I've sort of been with the team for over 7 years now, so that's how long this particular thing has been going. So it's not something you do overnight, implementing Raft and just make it work. It does take time to mature. But the one thing I thought of when we had that discussion was snapshotting. How would you do snapshotting if you have a lot of data in there? So that's kind of the first thing that would need to be solved before we could even start. It's sort of like a thought experiment. So, but I'll refer to back to my talk. It's very much going deep on the internals, and I don't have the right slides available to present that properly. So I think we'll move on to the new features.
Yeah, I know, Simon. What were the problems that you are trying to solve right now?
So I was working on a ticket called reconcile quorum queue membership periodically, and background of that ticket is an issue created by Michael back in February. I can share my screen maybe and show the ticket just to here we go, just so we know what we'll get some kind of context. That's my screen sharing work.
Yep.
Okay, perfect. Yeah, so this is the background for the PR that I've added recently, where for the new queue types, or for quorum queues and streams that use Raft, there weren't really any tools to or automatic tools to maintain a size of the queue that you maybe had in classic mirror queues, because there you had policies, for example, that we could so that RabbitMQ made sure that the size of your clusters, or like the membership of each queue, was at least spread on all nodes or on a certain number of nodes. But for quorum queues, you could only specify that when you create the queue. And then there are command line tools to grow the queue or shrink the queue. And I think there are even REST versions of those tools available now or in the future as well. But that was basically the only way for you to manipulate the size of the Quorum queues memberships. And this works great, but in some scenarios, you might have different teams that operate maybe the brokers, and then you have the developers who use the brokers, and the team who operates the brokers, they might have requirements on the systems, so they know that the system or the clusters are healthy, and that could be that there is at least 3 members per queue or for Quorum queue or 5 or something like that. So my stab at this, after discussing a lot with the maintainers, with Carl and Michael and all, was to add a feature called a periodical check, basically, that checks whether or not the queues that's on the cluster has the minimum number of members that we want. So I created a PR that is actually merged now, so it will be in future versions of RabbitMQ. That does this periodically. So it's a fairly simple, straightforward thing. It does what you would manually do, but with configuration, so it knows like what you want to grow to and things like that. So it's every now and then the system will go through all the Quorum queues. It will look at configuration or policies or arguments for the queue to see what the target group size would be. And if the group size is not reached and there are enough nodes, we would automatically try to grow the queue towards those nodes. That's the logic, how the algorithm works in the background, and there's a bunch of different ways you can configure this. Like I said, it's either per configuration or like the static configuration, or it's through policies, or it's through the argument. And if you have all these configured at the same time, we use the max value of whatever you want. So there will be at least a low bar number of nodes that you have in your system. That's the why and what the feature does. The journey to the feature, why we chose to do it periodically, was a bunch of back and forth. We started out developing this in the Raft implementation itself as a callback. So Raft or the RA library would notice whenever a node joined or exit the cluster and call a callback where you could decide whether or not the queue should grow or not grow towards that node. But there was some worry that that might not be efficient in the end, so we went for an easier solution, which is just a periodic check. And I guess that's the high explanation of the feature. Any questions or unclearness?
One thing that is never clear is how to talk about clusters. Like there's a RabbitMQ cluster, let's say 3 nodes, and then there is a Quorum queue cluster, and each Quorum queue will have a cluster. And very often both are 3 nodes, or well, both types of cluster are 3 nodes. There are 3 nodes in the RabbitMQ cluster, and each Quorum queue in that cluster is a separate Raft cluster of 3 nodes. And then it's relatively simple, let's say, because it's the same thing effectively. It's just there are different mechanisms to maintain that, but ultimately it's the same set of 3 entities. But for example, yeah, if you have a 5-node RabbitMQ cluster, you may have 3-node Quorum queues in that cluster. Yeah, it's just something to keep in mind when people talk about clusters and joining and leaving. It's like you can have a Quorum queue member leave the group, as we call that. I know Kari is not very happy with that name, but this is what we went with a few years ago, and it is what it is. So yeah, there's the initial group size. So when you created a Quorum queue, by default, it will use up to 3 nodes to host the members of that queue. If there are more nodes in the RabbitMQ cluster, it will just use 3. If there's only 1, well, it will be 1. And yeah, the idea here is that if, for example, you start with 1, but then you add 2 more, these Quorum queues should grow as well. If you set the target. group
And
size.
that also one of the, not drawbacks, but the initial group size that you specified, that is only used during creation of the queue, like you said. So even if that's the size you want your quorum cluster to be, if something happens to a node, you have to replace it or something like that, or one node goes down and you still have other nodes up, that queue wouldn't necessarily change unless you manually went in and somehow kept track of what you wanted that queue membership size to be. So this kind of addresses that pain point as well.
So if it replaces manual changes, would you say that you shouldn't do any manual membership changes if you have this feature enabled?
No, I think that's fine, right? Because what this feature kind of guarantees, for at least if you're, or like you operate the brokers, it's that you have like a minimum level of the size for your quorum queue. But if it's larger than that's okay, right? If you have 3 nodes and that's like what you as an operator want it to be, but higher is also okay, then the user could increase that value to 5 members or something like that, which is totally fine. But if they try to lower it, we want the system to notice that and say like, no, that's actually not okay. Let's go up again to the target we specified.
So you can't go below the limit, but you...
Right, you can go below it, but you can absolutely go higher if you want to.
Yeah. All right. So you can still set an initial group size, and that will be left.
Right.
Yeah.
That absolutely. So if you set it to 5 and the target is 3, we're happy with that. So it's just it's not a static number. It's like the minimum target value, or I guess is another word for it.
Yeah. Should we mention that auto remove configuration, perhaps?
Right. So there is part of this is also a configurable setting of this. This is like also the auto removing of a node as a member. Which could occur, so kind of like an auto cleaning, which could occur when we do this periodical check. We notice that there are members in the quorum queues that are no longer part of the cluster. And if we notice that, we would start to automatically remove them. It's not on by default because it could lead to situations that we haven't really figured out yet how to handle, where an old node comes back and is still and joins the cluster again, and that node still has that queue on it, and it will become I think a separate or 2 queues in the same cluster, but they live on different nodes or something like that.
Yeah, it could trigger a race condition, right?
Yeah,
sure. I mean, even the whole thing, what we realized was that the resetting a RabbitMQ node without forgetting it from the cluster means that the appropriate shrink operations on quorum queues isn't executed. So it means that it will start a fresh member. It still thinks it should have a member, and if you rejoin a reset node with the same name, it still thinks there should be a member, so it starts a new one rather than and that could sort of race with the auto remove feature and get a little bit tricky. So and I think that sort of highlights why it's taken this long for someone to implement it. we never did it because you know there is you know, membership changes is something that, you know, you should be careful with, and we've gone through the logic several times to try to build as much care into the decision making as possible, to check that the system is really ready to grow this queue. So yeah, it's looking very, very promising and useful feature.
yeah, it's been a fun project to work on, and soon with Alex change coming in, we could make it even more efficient, hopefully.
We do.
I'd like to add that in general, in RabbitMQ, we have a similar feature, a part of the cluster peer discovery subsystem, that allows you to delete nodes if they are not around for longer than, I don't know, a few minutes, let's say. And the original use case was, let's say you have a cluster that is deployed and uses AWS or scaling groups or whatever the alternative is in your favorite cloud. Yeah, sometimes nodes just fail and they're replaced, so their original identities are not coming back. But what we have definitely learned over the years is that this feature can be very dangerous. Imagine a group of people where one person has amnesia. Reaching consensus on that group, it's going to be pretty complicated. This is exactly how it works for, well, just RabbitMQ nodes. The most extreme scenario of that can be found in a great show called Dark Matter. So watch that if you'd like to see what that might look like. So we generally recommend extreme caution around a feature like that, because we routinely see that a node was stopped for maintenance that was supposed to last for 5 minutes, ended up lasting for 15, and that node is kicked out of the cluster, but then the operator tries to manually rejoin it. And yeah, it doesn't work very well. The outcome is a lot of confusion on behalf of the person, on behalf of the cluster nodes. So this is exactly the same line of thinking. In RabbitMQ, a feature that automatically deletes something, well, we would take a few years before we actually add it and then maybe make it a default. The aforementioned feature that removes cluster nodes, it is off by default, you have to opt in.
All right, Alex, Simon mentioned a feature that you are working on. What is it?
Sure. Yeah, when Simon and I were starting this team about a year ago, it was already clear to us that Quorum queues are a major milestone for Rabbit. And we wanted to operationalize and simplify the operations of it as much as we can, so that the Quorum queues become as much of the hands-off tool as possible. And one of the things that I think I stumbled for, but we stumbled on, was that Rabbit, not because of its fault, but how the system is built and all of its dependencies, misreports the queue health status when a fresh member joins cluster and starts to synchronize up to the current state of the state machine. I have a very simple demo here that will illustrate it. To avoid the infamous demos bug, I have it pre-recorded. All right. And for a bit of background, the Raft algorithm itself relies on Quorum. And very briefly, again, as we have a number of members in the cluster, not all of them are required for the cluster to progress. There is a tool in Rabbit that invokes Raft itself, its internal APIs, to poll if the current cluster is in danger of stopping making progress when this current member goes down. This would be the case when, for example, you have a cluster of 3 nodes, one of them is missing, and then you run this tool and it just reports that, yeah, if you set one more node down, there will be one remaining member, and that is not enough for a quorum, not enough to make progress. Which, in this example, I am illustrating with a queue that has a million messages chosen empirically. That is not in critical state, obviously. And at the bottom, I'm tracking state on its last member, on the 3rd node. So you can see this very item here says that the member is at the millionth element. And when the queue goes shrunk, this 3rd member disappears. There is no state on it. And the tool reports that, yes, if you set one more node down, this queue becomes unavailable. So far, perfect. The problem becomes when we grow back and the new member joins, in that the tool itself does not actually count the state of the member. So when you try to check if the node is quorum critical in the current Rabbit's version, it does not actually register that the newly joined member is still synchronizing up, and its last applied index, so its current state, is far behind the quorum state. Or let's say it's just doesn't have full picture of the queue and its messages, which means if you do send one more member down while that third member is synchronizing up, the quorum will not be able to make progress. This is like a very minor deficiency that supposedly is relatively easy to fix, and we could have done it in Rabbit itself. But thinking about it and reading upon the Raft implementation itself, I discovered that this is a problem well discussed and even fixed in certain Raft libraries out there. It is touched on in thesis. It is actually mentioned in our Raft library's issue board. There was an issue from long ago to add this thing that's called non-voting members. It's like a side feature to Raft, an extension. And that is what I was working on. With non-voting members added to the library that Rabbit will be using for Raft, the same situation, the same workflow results in a different state. The same sequence of commands, the same third member being observed, the same queue, but the difference is obviously insidious. It's in the second part of this demo, in that when that third member is removed and then added back, it will still be reporting the queue as critical until that member synchronizes, until its last applied index is fully up, reaching the leader or the quorum state. And we can see how it keeps saying this unavailable, will become unavailable, while the member is going up through the log. And well, this demo is a bit longer because I'm just waiting for it to go through all million messages. But eventually, when it goes up there, the state here from lowercase f as follower non-voter will change to uppercase. And all the internal tools will understand now that this newly joined member is fully capable of being part of the quorum. This is done in Ra, the Raft library itself, so hopefully it will benefit wider audience. But of course, very shortly, it will be merged as a feature to Rabbit. That's it.
Awesome.
It's very interesting. Yeah, thank you, Alec. It's very interesting that this feature, non-voting members or witness replicas, or however you want to call it, at least 3 teams tried it in the RabbitMQ community for entirely different reasons and arrived at, well, somewhat similar designs, or at least for the need to change this. And the fact that it is mentioned in the Raft thesis of Diego, I don't remember the author's name, sorry about that. Yeah, tells me that apparently this is a must-have for, I guess, a lot of distributed data services and the Raft library itself. And it's very exciting to see this come into Raft, to RabbitMQ's Erlang implementation of Raft.
Indeed, yes. Being able to track a follower that is not capable of being part of the quorum fully, indeed is like it's useful not just for these long queues, but it may be used as a tool via Ra API for various other purposes. For, as you've said, witness replicas, maybe passive followers, recovery, etc.
Yeah, it's great. It's just one of those features that never got implemented because no one really noticed that it was needed. Sometimes you just need to prioritize, but it's great. Yeah, thank you for that. And I think what's what I found different about Alex's attempt is that it's actually quite simple. It doesn't, and I think that's partly why we sort of backed out when with Simon trying to implement that feature, his feature in RA, and then backed out of that, is that sort of I had a change of heart, and the more I think about it, the fewer features I want in RA, and I wanted to become more of a very solid core with very good performance, and there are features that sort of going to improve that. But I think this is very much a core feature, where sort of growing, changing the membership automatically is fitted better outside of RA. So it's a great thing. One thing I noticed when I was testing your PR is that some of our tooling don't work very well when you're querying members that are catching up. So I'm doing a bit of work on that as well. The Quorum status command will time out against the member that is up but recovering, which it shouldn't be doing. If anything, it should report where it's at with like this tool we saw, the observer tool, should report where it's in terms of it's.
It is a work in progress. There are some kinks to be ironed out, and when it's ready, we'll work on. Well, I'll work on merging it into Rabbit.
Yeah, no, it's great. Miel, did you make that? You made that tool for a plugin for
The
observer.
observer plugin, yeah, I worked on that.
That's great.
It was very nice to see that. It's not really not widely known.
Super convenient.
Observer is, let's say, pretty well known. Although I'm surprised how sometimes people who have been using Rabbit for a long time do not realize there is a tool like that. But yeah, then Loic added a few months ago a plugin for classic queues. And yeah, quite recently, just a few months ago, we added one for Quorum queues as well. It's hard to put all the details of a Quorum queue on a pretty simple screen. So there are some limitations. We could not see the full value of those numbers that keep growing and so on. But yeah, that's for a good demo.
Each Quorum queue members has something like 60 odd counters that you can inspect if you want to. But most of them are not exposed anywhere in RabbitMQ, because it's just, you just want to expose the stuff that you can actually, try to derive some details from. But yeah, this is very exciting, and it will certainly increase availability as well, right? That's sort of one of the features as well. If we grow a queue from 1 to 2 members, right, and it's got a backlog, you're not going to be able to do anything until the second member has caught up. And now you can still operate in one node mode. You might get a little blip towards the end, but it's a lot better than having to wait for the whole million messages to replicate before you can publish your next one. So yeah,
and it can be even more important for Capri. So Capri is also based on RA, and will replace Mnesia for metadata storage. And yeah, that's probably even more important, because if a Quorum queue has a member that is not up to date with the log, well, worst case scenario, you have an unavailable queue, but with unavailable Capri, pretty much nothing works.
Definitely it will benefit that. It's funny though, I think one of the most challenging things for the Capri team is how they maintain how they create and modify and maintain the Capri cluster. So it's almost like a merge of the two features. Not that the Quorum queue feature will help at all, because it all needs to be done on node joins and stuff like that. But it's quite a lot to work out, and they're making great progress. But it is tricky. It's one of the sort of the trickiest bits of Raft is, yes, it's safe to change the membership, but how do you make sure you have the membership you intended and not 3 clusters that are all independent and things like that? And I think all Raft implementations have had a phase where they sort of, oh yeah, we split clusters all the time, and then someone wants to deploy it in a certain way, and again you have split by clusters again. So it's a challenge, but it's making great progress. I'm very pleased that people are contributing to RA. Yeah, so thank you.
Yeah. Anything more about these features?
I think it's one obvious area where this will help And in fact, you don't have, well, you as a RabbitMQ user or operator, you don't have to do anything. Instead, it will make your upgrade safer if those CLI commands, I happen to be the author of them, check if node is quorum critical and so on. Their goal has always been to give you some idea about, is it okay to continue with the upgrade of this specific RabbitMQ cluster member? So with this extra safety, you would not, well, you would have fewer, at least, false positives, and you get it for free. There are absolutely no steps to adoption. You just upgrade, right, when it ships.
Yes, yeah, it's a very slight difference in that in both cases it is relatively safe to do the upgrade, right? The quorum queue doesn't disappear, but it's just that it's now going to be possible to do it without stopping making progress to the queue. Yeah.
Worth mentioning that if you use RabbitMQ on Kubernetes with the operator, these commands are already executed for you, so you don't even need to know that they should be run. If you just deploy with RabbitMQ operator and you perform rolling restart or rolling upgrade, a node will not go down as long as these commands return that any queue would be unavailable if that happened. So it will just keep waiting, and with this feature, it will keep waiting for longer if needed.